In many disciplines, you have to take measurements. Sometimes those measurements are so minute, they're difficult or impossible for the human eye to determine. So a ruler or tape measure can't help. What you need instead is a precision measuring tool called a dial indicator. On this dial indicator, each graduation is 0.001 inches. A full revolution of the hand measures 100 thousandths of an inch. To make a key component called the bridge plate, this automated punch press stamps out brass circles, which are about 2 inches in diameter. Workers place each bridge plate into a manual punch press which makes location holes that will correctly position the bridge plate on the next press. This press makes holes for mounting screws, locating pins, as well as for 3 precision jewels, which reduce friction on moving metal components. This lathe begins the process of shaping a stainless steel rod into the dial indicator's main measuring component called the rack. Under a shower of cutting oil, the machine drills and threads a hole on each end for attaching a contact made of plated steel. Next, this milling machine cuts teeth, spaced 25 thousandths of an inch apart. One of the dial indicator's gears runs along these rack teeth to turn the hand that displays the measurement. This computer-guided machine forms an aluminum bar into another key component called the bridge. The bridge has holes for screws and locating pins that align with those in the bridge plate, so that the two can fasten, sandwiching the gears in between. The bridge also has holes for 3 jewels, which workers insert with a punch press. Jewels are donut-shaped synthetic rubies set in a brass ring. They line the holes for the gears and other moving components. The jewel surface is very smooth, so it eases friction on the component. Workers check every jewel under a microscope to make sure it didn't crack when pressed into the hole. The dial indicator's outside case is made of aluminum, shaped by this computer-guided turning and milling machine. Workers spray the case with powdered paint, using an electric charge to draw the particles onto the surface in a thorough, even coat. Then they bake the case in an oven for 20 minutes to make the paint finish ultra-durable. They put the case on a machine that presses in top and bottom steel stems, which will hold the rack in place. They mount a hairspring on the bridge plate. This spring allows the gear to return to its original position after moving the rack upward to take a measurement. They insert what's called a pinion for the large dial hand in the center jeweled hole, and a second gear into the jeweled hole for the small dial hand. Then they attach the bridge. Next, they insert the rack into the case through the stem and screw a contact into each end. Then they install a brass spring-loaded rack guide. It prevents the rack from rotating so that its teeth always face the rack gear. They mate the case with the rest. Then they push in the stem while holding the hand pinion to wind the gear. They install the printed aluminum dial on the bridge plate side and mount the hand for the small dial on a pinion protruding from the top of the gear. They mount the large dial hand onto its pinion. They place the movable dial into a grooved ring called a bezel and snap the bezel onto the case. When you turn the bezel, the dial moves with it. The back of the case is shaped with a lug for mounting the tool to a fixture. The movable dial lets you zero the indicator. You lock in the dial position with this twist bolt. The factory tests every dial indicator with this micrometer head. It pushes in the rack to a specific measurement. Every time the large hand rotates a full revolution, indicating 100 thousandths of an inch, the small dial hand clocks 1 graduation. This test guarantees no tool leaves the factory without delivering made-to-measure accuracy.